Hey everyone, welcome to Module 10. This week we're going to be talking about how do we describe graphs. So last week we talked about how do you identify the difference between a good graph and a bad graph. I showed you guys some tips on how to spot them. I showed you some examples. So this time, now that we know how to find the good graphs, right, or now that we know how to identify the good graphs, we're going to talk about how to describe them in a proper way. But before that, I want to just go through some announcements. So remember, today is the last day. Today is Wednesday. If you're watching the video today, today is the last day for your quiz 4. So let's take a look at that. If you haven't already, make sure you go to quantitative reasoning, information, and tasks. Click on that, and your assignments and quizzes will be right here. So the only quiz that's open right now is quiz 4. By the end of this video, I'm going to open assignment 3 as well, which I'll talk about in a bit. But quiz 4 is based on the video that was from last week, so make sure you watch that. It will be open until midnight today, right? But don't wait till last minute. It's a handful of questions, but most of them are multiple choice and true or false, right? So you will not be showing any work for this, and you will not have to upload any work, right? So make sure you get this out of the way, right? If you watch the video, this right here, interpreting graphs and charts, if you watch that video, they'll give you a really good understanding of what you're supposed to know for the quiz. Okay, so this week, again, we're going to take what we know from last week and we're going to talk a little bit more about graphs. Alright, so like I had mentioned, this week we're going to be talking about describing graphs. But before that, let's talk about some announcements. So like I had mentioned, today quiz 4 is due by 11:59. Make sure you do that. As I showed you on Blackboard, it's located on Blackboard. You go to the quantitative reasoning, information, and task page, which is on the left hand side, if you remember. Then you go to the assignments and quizzes folder, and then quiz 4. Assignment 3, which I'll show you later on at the end of this video, that's due by next Wednesday. It was usually due by Sunday, but the reason I pushed it back is because this Sunday you have something else to do. You have your integrated assignment 2 outline due. So remember what that outline is. I talked a little bit about it in last week's video. Make sure you go on the integrated assignment folder on Blackboard to view that. Remember, on Blackboard you click on integrated assignment 2. So the due dates, the outline, which is due this Sunday. You have to give a clear plan of your project, explain your theme, topic, research questions, and this is every member does that, right? And 2 data sets for the QR components. The 2 data sets are very similar to what this assignment that we're going to be talking about today is, but make sure you click on the guidelines, click on the guidelines to get more specific information about that. And also last week's video talks more about that. Tell us what piece of assignment each member will be responsible for and the cardio worksheets. So that's all due by Sunday, end of this week, right? That was the main reason why I had pushed back assignment 3 to November 25th, right? Also, something else that I want to keep you guys on your mind is the House 6 student survey. Remember, so we posted a survey and we just want to know how the students are doing in other classes comparatively, and we just want to know what classes are you doing good in, what classes are you having a little bit of trouble in. So we just want to know how every student is doing, and the more feedback the better for us, and how we give back feedback and how we construct our courses. So that's really important that you do that survey. Okay, so let's get started on this week's work. Now, when it comes to graph descriptions, there's a lot of different ways to describe one simple graph, right? You guys heard of that term, picture says 1,000 words. Well, same thing with graphs, right? Everybody could describe a graph in a different way, but there's right ways and wrong ways of describing a graph, right? There's key points that you want to talk about, and there's some necessary stuff that you want to talk about, and then there's unnecessary things that you don't want to mention in a graph. So it's really important how, when you see a graph as a presenter, that you're presenting and you're talking about the key points and not just all of the information that's in a graph. So currently, unfortunately, the most famous graph in the US is this one right here. Now, this was taken from the New York Times this morning. This shows newly reported cases of coronavirus by day in the United States. So each one of these bars shows the daily number of cases in COVID cases, and the red line shows the 7-day average, right? So what is the 7-day average? The 7-day average is, it takes the average of that day and the previous 6 days, and it averages it, right? Averages, you add up all the numbers divided by, in this case, 7, right? Because it's a 7-day average. So we get kind of like a trend that we could follow, right? Because it's hard to follow the actual raw data. If we were to see it, it goes up and down, it fluctuates, right? So that's why statisticians use 7-day average to get a better trend and understanding of which way is swaying, right? The reason why, from looking at this graph, we say there's a third wave, which is the biggest there's ever been, because we see the trend of the cases going upwards in an exponential way, right? So the way you would describe this one right here, right? You would say something like the cases would started around mid-March, and there was a peak around mid-April. Early summer, it started, the number of COVID cases actually started decreasing, right? As you see through early summer, meaning up until June, right? Midsummer, there was a huge peak, right? There was a huge peak midsummer after 4th of July. So this could have been because of the 4th of July. Everybody was partying, gathering together, social gatherings around mid-July. That's why we had a huge peak that followed afterwards. Then near the end of the summer, we had a decrease. At this point, what did we decide to do? We decided to open up indoor dining, specifically in New York City. We opened up indoor dining in New York City. The restrictions were a little bit looser, and look what that caused us, right? That caused a surge of increase in cases that saw, which we see up until today, right? You see huge cases. So here you see spikes. Sometimes it's a little bit lower, sometimes it's a little bit higher, right? But the trend line, in this case the 7-day average, basically shows you the directions going, right? That's why we use the 7-day average. Now it's easy to tell what the axes are telling us, right? The horizontal axis is showing us the months, and each one of these red rectangles represents a day. The vertical axis showing us the number of cases starting from 0. Notice how, like I had mentioned last week, we start from 0. We don't start from an arbitrary number. We start from 0. That way we see the scale, and everything is well defined within that scale. Now let's look at a different graph. Here we have another graph, and this one is showing us the deaths due to COVID by day in the United States. Here again we see a peak around mid-April. Then we start decreasing in the number of deaths. See, again, we have a 7-day average. It's very important that we look at the 7-day average and not these single day, because as you can see, it fluctuates a lot, right? Some days you have really high, some days low, high, low, high, low, and it changes on a week basis, right? So that's why statisticians, again, use the 7-day average. Now, there's some key points that the New York Times made, was that many deaths from unspecified days, right here and right here, right before July and middle of July. There were some days that there was a big peak in deaths, which sometimes are unexplainable, but that's the reason why we have these averages. That kind of levels it out, that kind of smooths out the trend of the graph. Very similar, we see a wave, increase, right, near mid-April, then decrease throughout the summer, and then again a peak in August, and then down near fall, and then slowly starting to get up, right? Which is very indicative of what's happening here, right? Here in the deaths, we had a lot more deaths in the beginning, right? Again, the months are in the horizontal axis, the number of deaths is on the vertical axis. The reason we had a lot more deaths here, as many of you guys may already know, because this was relatively new to us in the United States, so we didn't know how to treat it. We didn't know we didn't have enough equipment, we didn't have enough PPE, we didn't have a lot of things, right? We were just not supplied enough to deal with this, and that's why we had so many deaths in the beginning, even though the number of cases was relatively less compared to what it is now. Thankfully, we have more equipment now. But as you can see, there's kind of a lag, right? A lag means if an event occurred, something else occurred relative to that or associated with that event, right? But in a later time period, right? And as you can see, there was a peak around early April, but the deaths happened late April. Then another peak around mid-July, right, in cases. Then the deaths followed late July, early August, right? As you can see, there's a pattern, right? Whenever there's a peak in cases, and this shows us, the graph shows us, whenever there's a peak in cases, about 2 weeks later, 2 or 3 weeks later, there's a peak in deaths. So unfortunately, if we follow these graphs, right, and this is how we make inferences and intuitions, and this is how Dr. Fauci and Dr. Birx and all these doctors and epidemiologists can say that by the end of this year or by the beginning of next year we could have this many deaths, because they follow these graphs, right? So there's a peak here, there's a peak in cases now, so that means in a couple of weeks, unfortunately, there might be a peak in the deaths as well. That's how they know, right? I know this week's video is probably super ominous, super downer, right? But it's important understanding these graphs because you see them every day, right? You turn on the news, you go on social media, you see these every day, and it's important that you understand the facts that are being presented from these graphs, right? And understand how are these being created, right? So let's talk a little. Let's go talk about one more graph. Now here's another graph we're looking at, right? And there's a bunch of information in this graph, right? I used to teach course in climate change, so I love this graph and courses on graphs on climate change. So we're going to be talking about that for a couple of minutes in the next couple of slides. But I want to start off with this one, right? Because there's two bits of information that are being shown here. One is the CO2 or carbon dioxide emissions, right? How much carbon dioxide there was in the air, and also the temperature that was recorded at that time. Now this is prehistoric times, right? So we're going back 800, 600, 400,000 years, right? And the way we do that is we look at ice cores, we look at data in ice cores, and we look at tree rings data, we look at pollen data stuck in many different types of fossils. So there's a bunch of different ways to backtrack carbon dioxide and temperature, right? There's a lot of really good documentaries on recording data, prehistoric data. So take my word for it. This comes from the National Climatic Data Center, so they know what they're doing. So what this is showing you, this graph, right? The dark blue line is the carbon dioxide emissions, right? So how much carbon dioxide there is in the air. And the light blue shows us the temperature, that the temperature change from present, right? So how much the temperature is changing throughout the year, this kind of records that, right? Now, if you see that they overlap nearly identical, right? Nearly identically they overlap. Let me just describe what the axes are showing you. On the horizontal axis, you have the age from 800,000 years ago, and this is going backwards up till present, which is 0, right? So that's usually how we describe prehistoric data. Now, on the left hand, you have one axis, and the right hand, you have another axis. So this is a special type of graph. It's a double axis graph, right? And it shows you what the different levels are for each of these graphs. Now, the left hand shows you the temperature ranging from -12 Celsius, right? That's why it's mentioned, the units. Always important whenever you work with any kind of measurement, you mention the units, up till 6 degrees centigrade or Celsius, right? On the right hand side, we have carbon dioxide emissions in parts per million, so ppm, ranges from 160 to 320. Remember, like I always told you, you should start at 0, but the reason we didn't start at 0 here, because we're talking about different types of units that make sense. In this category, it doesn't really make sense to start at 0 because there are no values that are that low, right? The lowest value is around here, which is close to 170, right? So it makes sense to start at 160 here and then go up to 320. Same thing with here. You want to choose a range that makes sense. You want to choose a range that makes sense and has your data in it, right? If your data is not within that range, then it doesn't really make sense, right? And here, we're not really comparing, other than these two types of measurements, we're not really comparing temperature to another temperature, carbon dioxide to another carbon dioxide, right? So that's for that reason we could choose a range in the vertical axis that makes sense. Now, here, like I had mentioned, whenever carbon dioxide goes up, temperature goes up. Whenever carbon dioxide goes down, temperature goes down, right? So you see this nice pattern of relationship between carbon dioxide and temperature, right? And it's been prehistoric, even before humans existed, right? Even before humans existed, this has been the case for hundreds of thousands of years, right? Now, why am I showing you this? The reason I'm showing you this is because I want to relate it to this other graph that I usually show my climate change class, right? Now, this graph shows data from the National Oceanic and Atmospheric Administration. Yeah, that's what that was. Administration. Yeah. So they have observatory in Mauna Loa, Hawaii. It's a really cool place, and that records carbon dioxide at a very high accuracy. And as you can see, the red, right, and it's not described here, right? The reason I know it is because I see this, I use this graph a lot, and I read a lot about it. But what this is showing you, the red is the yearly or seasonally, carbon dioxide levels, right? The red is showing you that. So it's going up and down. So during one season it goes down. During the summer seasons, it goes up. Summer season is going down. The winter season goes up. Summer season goes down. Winter season goes up. So up and down. That's what the red is showing you, right? Because trees and plants take in carbon dioxide, right? They take in carbon dioxide. So during the summertime, when there's a lot of plants that are alive, they're taking the carbon dioxide, right? That's just a very generalization. I was thinking about this. There's other factors as well, of course. But during the wintertime, those trees die off and they release carbon dioxide again, right? But trees aren't the only thing that are releasing carbon dioxide. Humans are emitting a lot of carbon dioxide. And I want to get to that, right? So the red is showing that. The black is very similar to what we saw before. This is a trend line, right? This is averaging in yearly, is averaging the yearly carbon dioxide. So we're getting a trend that's going upwards, right? So carbon dioxide has been increasing steadily for the last at least 60 years, right? At least for the last 60 years. And here is the horizontal axis. Parts per million is the vertical axis. Now look at this, right? We start at 320, we're shooting up to 420, and it's just increasing. There's no trend of going down, right? This is going up. Now, prehistorically, looking at this, we don't even reach 320. Maybe sometimes we reach 320, right? Here, since the Industrial Revolution, right, we're starting near there, and we're just going more and more up. The amount of carbon dioxide that we're releasing is on another scale than that has ever been seen prehistorically, right, up until even 800,000 years. So that's why it's really important. And as you know from this graph and the previous graph, when you have higher carbon emissions, what does that mean for temperature? It follows, right? We know that whenever carbon dioxide goes up, temperature goes up. Whenever carbon dioxide goes down, temperature goes down. So this means that temperature is going to also start increasing. That's why we have the whole idea of climate change. And that's why we started with global warming, the term global warming, because there will be a warming of the world, right? Due to the emission of carbon dioxide. It usually happens because of unsafe industries just releasing carbon dioxide and many other types of pollutants into the air, and also cars, right? That's why we want electric cars. That's why a lot of people go for electric cars. Obviously that has its own pros and cons, but in general, electric cars do not produce as much carbon dioxide as gas cars, right, or regular cars, right? So that's another thing why we're trying to go green, right? We're trying to have less industries that cause a lot of carbon emissions. The reason why is because carbon emissions go up, temperatures go up. And what happens when temperatures go up? Well, everybody likes the summer, right? Everybody likes a little bit of hot temperatures. Some people prefer it over the cold. But what does that mean on a global scale? On a global scale, when you have, and let me, right? So first thing that happens, one of the first things that happens when you have increase in temperature worldwide is ice caps melting, right? Ice melts because it's getting hotter. That's just common knowledge, right? Now, because of the ice melt, what happens? These penguins, polar bears, and many other Arctic animals lose their home, right? And when they lose their home, they die, um, and that's bad for the ecosystem. That just messes up the ecosystem chain, right? We don't want that. Now, let's say you don't even care, right? And I'll be frank. Let's say you don't care at all. I do, but let's say you don't. You don't care about penguins. You don't care about polar bears. What does that have to do with any of us, right? Now, ice melting also means what? Sea level rising, right? Because what happens to the ice? It melts and becomes water. So once water increases, the sea level in the world increases as well. And what happens then? Then you have something like this. As sea level increases, right? And you guys might know the number of storms that are happening now are on an unprecedented level, right? The amount of hurricanes we're getting in America and around the world is just increasing day by day, right? And it has a lot to do with climate change, right? When you have an increase in sea level, right? So let's say you have the shore right here. You have a house, right? Some people have their houses right next to the shore, right? In 2010, let's say if we had a regular amount of sea level, when you have storm surge, which is when a hurricane pushes, right, the water doesn't really reach. It maybe takes down some houses, but not all the houses. In 2050, when you have sea level rise even more, then the storm surge comes even further into mainland, right? As you can see over here, it doesn't go that far, but you go more and more into mainland by 2100, right? And this is an exaggerated graph, but the idea is there, right? If you have sea level increasing over and over throughout the years, right, storm surge will get more and more inland, and you'll have less land to live on. Less land to live on, meaning less people living on those parts of the world, right? And those parts will drown. Venice is a place is a city that's drowning, right? It's literally sinking day by day because of increase in sea level. My country I was born in, Bangladesh, it's drowning, right? Sea level's increasing, so every day part of the beaches are becoming inundated with water. So less people have to move more towards the inland, right? More into the land, right? So there are hundreds and thousands of millions of people that are being affected by this, and all of this. And I know I kind of spiraled into a whole climate change topic, but it all comes into play because of, if you understand how to read a graph, you could start connecting dots, right? This simple graph that talks about carbon dioxide and temperature from 800,000 years ago, which has nothing to do with us, right, at first glance, has to deal with many people losing their homes, many people losing their cities, many people losing their countries, those islands in Indonesia, and being underwater because of sea level, right? So it's really important that you understand how to interpret a graph, right? And how to find relationships between one graph and another, right? Now, how does that relate to our assignment? So when you click on integrated assignment, excuse me, so when you can click on corner of reasoning, information and tasks, you click on assignments and quizzes, right? As long as well as the quiz that's due today, Wednesday today, if you're watching the video. You also have assignment 3, which is interpreting and describing graph. In this assignment, you are asked to find 3 graphs from credible sources that you find interesting. These graphs can be related to your integrated assignment theme, but are not limited to them, right? So you don't have to choose something that's related to the integrated assignment. But if you do, that's fine. But you have to choose 3 graphs from credible sources, right? And this is due by the 25th. So let's open it. So for this assignment, you will again find 3 graphs. You need to copy and paste each of the graphs into a document, right? And then for each graph, you must answer the following questions, right? So 5 questions for each graph. So altogether, you're answering technically 15 questions, right? 5 questions, just 3 times, 1 for each graph, right? First question, what is the main idea of the graph? What is the presenter trying to convey, right? So what are you trying to get out of the graph, right? What's so important about it, right? What is it trying to tell us, right? In a sentence or two, describe that, right? Next question, why did you choose this specific graph? How does it impact you, right? Why is it important to you? Why did you choose it? What stuck out to you, right? Write about that. Third one, what would you change about the graph, right? Now, it could be an informational change, or it could be aesthetic change, something that you want to change, but the looks of it, right? There's always room for improvement. For every type of graph, there's always a room for improvement, right? So that third question is asking us about what would you change, right? Just to give you an example, in this graph, I would have them mention what the red is indicating and what the black is indicating on the graph, right? So that's important, right? Something like that, they could mention that on the graph. Fourth thing, if you had to ask the creator of the graph a question, so whoever made the graph, if you had to ask them a question, what would it be, right? So what do you want to ask them, right? If you had a chance to talk to them, give me a question that you would ask. Fifth, give me the source of where you got the graph from, right? You can copy and paste it, just a link. If it's a website, just copy and paste it. But remember, it has to be from a credible source, right? So by now you guys know what credible sources are, so make sure you have the source is not just a Google image, right? Make sure it's not a Google image. Make sure it's from an actual source. I'm going to give you an example. I went to the New York Times and I got both of these, like I had mentioned, both of these graphs. So what I would do is I would take a screenshot of this, right? If you're on the Windows, right, there's a tool called Snipping Tool, which lets you, if you just type up Snipping Tool in the search bar right in the bottom, if you type up in your computer, right, Snipping Tool, you click New. What it lets you do is you create a box around whatever the pictures or whatever you want to take a picture of, right? Here in this case, I missed out the graph's title, so I want to click New and then do it again, but I'll just close it for now. But yeah, so you would take the snipping tool, right click, copy it, paste it into your Word document. Right click, paste, and there you have it, and then you could start answering question 1, question 2, so on and so forth. You could start answering the questions, right? So that's how you do it, right? If you have a Mac or Chromebook, I'm pretty sure they have their own ways of capturing the screen. So just do a quick Google search. How do you take a screenshot of on your computer, whatever type of computer you have, right? Now, if you take a screenshot and it's the entire page, right? There's ways to crop it, right? If you have the entire page and you don't want the entire page, I think right click, crop, and just get it to wherever the graph is. All right, in this case, I want the entire graph because this is the entire graph. But if I had the entire web page or my whole desktop or my laptop screen, I don't want to show everything, right? I just want the graph itself, right? So try to zoom in to the graph, try to zoom in, get the screenshot, copy and paste the screenshot into your Word document, and then move forward, right? If you have any questions on that, you could ask me, send me an email on that. We could talk about it. But also, one more thing. So this week's discussion, if you click on the discussions link on Blackboard, you'll see it's the last one. It's up, right? This week's discussion. Again, like the assignment, I'll have this open until not Sunday. I should say Wednesday. So let me change that. Yep, due by Wednesday, November 25th. Right. So you could talk about this week's video on it. I had one student that had asked me about what was it? Oh yeah, the quality of the sound, right? She was having a hard time listening to that the sound. So if you could comment on that, and if you're having trouble with the audio quality, let me know. If I see a lot of people with that concern, then maybe it's on my end. If it's just 1 or 2 students, then maybe it's on their end. So I really would like to know the sound quality if you're okay with that. If there's any problem with that. Oh, one last thing. there's this really cool Spotify podcast on data and the public, which I want you guys to take a look at, and I want you to talk about in the discussion as well, right? So I'll update the discussion board to that. I'll email you this link. It's called Another Word Entirely, right? When you click on this, it's about 51 minutes, 51 minutes, something around there. So listen to that and talk a little bit about that and this week's video on your discussion. All right, guys, take care, and I'll see you in the next one.